Hopefully up until now, everything's pretty much made sense. You can see how we can use Firebase to manage the database for our application. We can perform all of those CRUD operations, CRUD being create, read, update, and delete. We can do all of those things, we can manage our data, but we're still missing out on some pretty important information. Think of your favorite app, any app. It could be Steam, it could be an iPhone game, it could be your favorite text editor, Gmail. All of these store list-based data. We have a list of games, a list of files, a list of emails, a list of unread emails, and we need to figure out a way to store that. So with a database like MongoDB, we have a collection of documents. With an SQL database, we have a table with rows. With Firebase, we have to figure out how we can store our list-based data. And it's important to note that Firebase does not support arrays. So we're going to look at exactly what I mean by that, and we're going to explore what Firebase does let you do to store this list data. It's just going to take a little bit of time for us to switch how we think about storing our data. Then we'll be able to get everything done we want to get done. In our case, we'll be able to manage our expenses, having a list of expenses for each user of the application. To kick things off, what we're going to do is delete the entire database. I'm going to start from scratch. We can delete everything, and over here, we're going to go ahead and comment out our line, making sure that we have no Firebase queries or CRUD operations running. To show you what I mean by saying Firebase doesn't support arrays, let's go ahead and try to save one. So for our application, let's say we're trying to create a notes app. We have a list of notes we want to be able to store and access. So I am going to create a const notes. I'm going to set it equal to an array, and each array item will just be an object, and the object will have various properties. This is pretty similar to what we have now in the Expensify app. For the first note, I could have an ID equal to 12. I might also have a body for the note. We can go ahead and set something up for there. This is my note, and I'll sneak a title in here as the second property. First note. All right. So we have our first note showing up. I'm going to take these properties and copy them down for the second note. All I'm going to do is change the data. For the ID, we can just pick something else. I'll go with 761 ASE. Then we're going to change the title, another note, and we can leave the body the same. So this is the data we want to work with in the end of the day, right? We want to use this data to save it in the Redux store, to render the components to the screen, and we really can't work around that. We need array data. Now, Firebase doesn't support arrays, so let's see what actually happens when we try to save this. All we're going to do is use database.ref. We are going to access a ref. We can just put this on something like notes, just so it's not on the root of the database. And then I'm going to use set, and we're going to set it equal to the exact array we created above. I'll just reference the notes variable. And now we can go ahead and actually save the file. It's going to try to save the array, and we can see what actually happens. So the first important thing to note is that we did not get an error. Firebase didn't throw any error inside of the console, even though we tried to save an array. But what we did see right away is that the data we're getting is not the data we probably expected. On the root, we do have the location notes. In there, we expected our array to live, and that's not what we're getting. Instead, we are just getting child locations. We have 0, which has body ID and title, and we have 1, which has body ID and title. So instead of working with an array, our data has gotten converted into an object-like structure, where the property on notes is just the index of the item in the array. So over here, the first item with the index of 0 shows up on the property 0, and the one with the index of 1 shows up with the property of 1. So what does this mean? Well, it means, first of all, that clearly Firebase does not support arrays. We tried to save an array. It didn't get saved as an array. It got converted over to this object structure. Now, what do we do from here? Well, you could say, hey, Firebase doesn't throw an error, so we could probably work with this. And technically, yes, we could work with this. But think about the real things we want to do with our data, with notes. We might want to update a note. We might want to remove a specific note, and we might want to fetch a note. And we're probably going to want to do this by something like the ID. So with the current setup, it's going to be really difficult to find a note by ID. Imagine we tried to set up some code over here to get that done. Maybe we use database.ref, we tried to find the reference notes, and it would be really nice to be able to take advantage of the fact that we can access a child location, something like 12 to get the note with the ID of 12. But in the current setup, when we try to force an array into Firebase, it's not convenient. We have these indexes, and these are pretty useless, they have no meaning, and it just makes things harder than they need to be. So we're going to focus on thinking about our data a little bit differently. Right here, we're going to go ahead and set up a const called Firebase notes, and we're going to see what Firebase is going to store our notes in. It is going to be an object at the root. Then we can have our property. Let's say we still call it notes. Now, this is not going to be an array. This is going to be an object. And in the Firebase world, the keys on this object, they're going to be the IDs. So they're all going to be generated for us. We might have a long one like this, and its value is going to be an object with the properties. So here we would just have title and body like this. Now this would be a application with a single note, the ID being this guy, the title being first note, and the body being this is my note. If we wanted another note in the mix, we would add another property onto the notes object. It's going to be unique by default since they are just object properties. I can type a really long thing in here. I can set it equal to an object, and I can take my data, copy it, and paste it up above. So in the end of the day, this is what we're going to be storing in Firebase. Anytime we want an array, we switch things up a little bit. We have a unique identifier, and we actually set its value equal to an object. That's where we put the quote-unquote array stuff. So if I have an array with title and body, I would put title and body in here. Now we have all of this in place, but the question has to be asked, how do we go about generating these random IDs and setting the values? Well, we're going to look at that right now. What I'd like to do is go ahead and comment out everything we have so far, though I am going to leave this in place so we can refer back to it in just a moment. Up above, what we're going to do is access database .ref, and we're still going to get a reference to notes. This is where we're going to store the notes data, but right here we're going to access a brand new method. This one is called .push, and all we're going to do is push in a value. So when we use push, Firebase is automatically going to create a new property on our reference. So in the case of notes, it's going to create a new property. It is going to give it a random value, and it is going to take what we pass into push, and it is going to set it right here. So if I want to have a list of objects, I would just pass an object into push. Let's go ahead and see what happens. I'm going to set the title equal to to-do, and I will set the body equal to go for a run. Now I'm going to add a semicolon on the end, and what we're going to do is save this file and see exactly what we get over inside of the Firebase data view. But before we do, I'm going to delete everything we have so far so we can start from a nice clean slate. All right, everything is deleted over here. Let's go ahead and save the file. I'm going to save it and switch over to the data view. In the background, the application should be refreshing, and we should see our data in just a moment. And right here on the root, we still have notes just like we did before, but instead of having something like 0 or 1, we have a really long generated ID. This is a unique ID, and if we crack open that thing, what's inside of there? It is our data. So this is how we are going to work with list-based data inside of Firebase. We're going to be storing it in this structure, which is exactly what we just saw down below. Now we could go ahead and add another note to the mix. I'm going to change things up. I will have a separate list for course topics. Inside of here, I'll do something like React Native, Angular, Python. I can go ahead and save Firebase again. It is going to add a new note into the mix, and that is going to show up inside of notes alongside of this guy. Here we go. We have a brand new randomly generated unique ID, and if I crack that open, we have our new data inside. So this is the structure that we're going to be working with when we store list-based data in Firebase. It's going to make it really easy for us to access an individual item to manipulate it, whether we want to just read the values, update some of the values, or remove the values. We can do that with just a reference. So let's go ahead and actually play around with that. Over here, I'm going to comment out the call to push, and down below, I'm going to delete all of the dummy notes data we created in this one. Starting to get quite a few comments down there, and I do want to clean things up just a little bit. So the goal is to figure out how we can access this this note to manipulate it. So we know we can get notes, and we know we could just grab the child location. All we have to do is copy this to the clipboard. I'm going to right click, copy the text value, then we're going to use it over here. We're going to access database.ref. We're going to get a reference to. We're going to access the notes location / the ID we just copied. Now we have a reference to that individual note and we can manipulate it in some way. Let's go ahead and use update. And I am going to change one of the values on there. I will just update the body of the note. Let's say I went ahead and went for my run and now I have something else to do. I can change that to buy food. Then I can save Firebase, and this is going to just update body on that note. Over here, we should see it update in just a moment, and there it is. Body switched over to buy food. We were able to access the individual note and manipulate its data. Now we could go a step further and just remove the note completely. So any of the methods we used before, we can use here. I could set the values, I could update, I could also just use remove, and this is going to completely remove that note. Let's go ahead and actually remove the note over here. Let's see what happens when the code actually does run. What is going to happen? We can see the item completely got removed. So there we have it. When we work with arrays, we're going to be using push to create those new things. We use push because it automatically generates the ID for us, as opposed to us needing to do that on our own. Now it is challenge time, so I'm going to go ahead and outline exactly what I'd like you to do, and we're going to do that just above. I'll add a few lines. You can feel free to keep all of that code down below and comment it out. You could delete it completely. You could move it to a separate file. The choice really is yours. But what I want you to do is focus on creating some expenses. So right here, we created some notes by getting a notes reference and using push. You're going to be adding 3 expenses to the Firebase database. So you're going to set up expenses with 3 items. All 3 items need the necessary data. We need description, an optional note field. You can leave it as an empty string if you don't want to type one in, an amount, which is just a number, and created at, which is also just a number. So you're going to be setting up these 3 expenses with 3 push calls down below. Right here, you're going to add those 3 push calls. And in the end of the day, over inside of the data viewer, you should see an expenses location. If you crack that open, there should be 3 things inside of it, much like notes has 1 thing inside of it here. I am going to go ahead and completely wipe the database so we can start from a nice clean slate. Take some time to add those 3 expenses, test your work, make sure they all show up over inside of the Firebase database viewer. Pause the video, and when you're done, click play. All right, how'd that one go? To kick things off, we have to create some expenses. Right here, database. We are going to access the reference. Where do we want to store this? We could put it on the root, but we don't want to. We're going to put it in expenses to stay nice and organized. Inside of expenses, we want to add items. We don't want to treat this as an array. We're not going to try to force an array in there. We're going to be using push. So push is going to generate that new property, and it is going to allow us to provide some values right here. If I wanted to store a string, I could store a string. I could pass in, this is some string, and it would totally work. So you don't have to pass an object into push. You could pass in any data type that Firebase supports. In our case, we just happen to want to save an object. So I will provide one right here. We're going to set this up with a couple of those properties we know we need. I'm going to add description. We can set description to something like rent. I'm going to set up note. We can leave note as an empty string. I'm going to set up amount. This will be stored in cents, so I will have 10,09500. That would be $1,095, and last up, created at, once again, just a number. We can just jam the keyboard a little bit and come up with some nice big number. This is going to allow us to create a single expense. I'm going to take this and just copy it 2 more times to add a few more pieces of data to work with. Right here, I could add something like phone bill. I don't know what my phone bill is. I think it's like $59. So I will do 5900 right there. Then we're going to go ahead and move down to the last one. So from rent, we'll switch things up. I already have rent. I already have phone bill. What else do I spend money on? Food. Food, let's say I spent $12. And we're going to leave the dates the same for all of them. Although you could change that and you could add notes. Now that we have these set up, all we need to do is save the file and take a look at what we get over inside of the browser. Hopefully we do see that expenses property with all 3 things showing up. Right here, I do have that. I have expenses. I have 3 unique IDs. And if I start cracking these open, we can see all of our expenses. We have rent first, all the data looks good. We have phone bill second, looking good as well. And last up, we do have food. Everything is correct. So at this point, we know how we can get data into Firebase that Firebase likes to work with. We also know how we can access individual items and manipulate them, whether we're updating them, setting new values, or removing them completely. Now, what I want to take the next video to talk about, which would be called something like Arrays Part 2, is how we can actually work with this data. So how do we fetch data out? How do we get it in a format that makes sense for us? How do we use other event listeners to listen for when expenses are updated, removed, or added? We're going to cover all of that in the next one. So let's just go ahead and jump right in.